11.2 kilometers per second, 25,000 miles per hour. That is the price Earth charges every spacecraft that tries to leave. Pay it or burn trying. There is no in-between, no almost, no nearly, no we tried our best. The universe wrote this number into the fabric of physics itself, and it has never accepted a discount. Right now, gravity is winning. Against your coffee cup, against your breath, against you, pinning you to a planet spinning at 1,600 kilometers per hour. And to escape it, you must move 11 times faster than a bullet. This is why rockets are colossal. The Saturn V weighed 2.8 million kilograms at liftoff. 85% of that was fuel. Its engines unleashed 7.6 million pounds of thrust, enough to lift a battleship straight off the ocean. And even then, the rocket crawled. Engineers call it the tyranny of the rocket equation. Every kilogram you lift requires fuel. That fuel has weight, which requires more fuel. It compounds, cruelly. This is why every screw is weighed, every wire, every drop of paint. NASA once removed printed labels from drink pouches just to save fractions of a gram. Because grams become kilograms, become tons, become failure. And failure is binary. A rocket that reaches 11.1 kilometers per second doesn't barely make it. It comes home, fast, often violently. In 1999, NASA lost the Mars Climate Orbiter, a $327 million spacecraft, because one team used metric units and another used imperial. The error was microscopic. The result was total. You either pay the full ransom, to the gram, to the second, to the decimal, or the chain holds. Cross the void to the moon, and the price drops. 2.38 kilometers per second. Barely a fifth of Earth's. This is why the Apollo lunar module looked the way it did. Spindly, fragile, wrapped in gold foil. On Earth, it would have collapsed under its own weight. On the moon, it was more than enough. But low escape velocity has a cost. There is no atmosphere on the moon because every gas molecule that ever drifted upward eventually crossed that number and escaped forever. Mars sits in between, 5.03 kilometers per second, almost exactly half of Earth's. And yet, we have never sent humans there and brought them home. Because returning from Mars is its own gravity problem. Mars's escape velocity tells a tragedy. Billions of years ago, Mars likely had a thicker atmosphere, possibly liquid water, possibly oceans. But at 5.03, Mars couldn't hold the line. The solar wind stripped its atmosphere away, molecule by molecule, over billions of years. Today, barely 1% of Earth's, a frozen, rust-colored ghost of what it once was. Now we approach the edge of comprehension. Asteroid 101955 Bennu, a 500-meter rubble pile of ancient rock. Older than Earth itself, its escape velocity is 0.20 meters per second. Not kilometers, meters, slower than a casual walk. If an astronaut stood on Bennu's surface, fully suited, and made a normal jump, the kind you'd make to grab something off a high shelf, they would not come back down. They would drift upward, slowly, silently, the asteroid shrinking beneath their boots until it was just a dark shape against the infinite black. And then a dot. And then nothing. A human-shaped speck of debris in the great wheel of the solar system. NASA's OSIRIS-REx mission had to use thrusters so gentle they barely qualified as thrust at all. On Bennu, gravity is not a force, it is a polite suggestion. Earth charges 11.2, the Moon 2.38, Mars 5.03. Bennu, almost nothing. But every world holds on to something. Every rocket that has ever escaped this planet paid a price the universe set, in a currency the universe wrote. On a contract, the universe never lets you renegotiate. You hit the number, or you fall. The next time you feel the ground beneath your feet, remember, it isn't just holding you up, it's holding you in. Now look down at your feet and ask yourself, are you standing on Earth or being held prisoner by it? Comment your answer and share this with someone who thinks space is easy to reach.